Good morning everyone. Welcome to my classroom. Welcome again to another math tutorial. Before watching this video, don't forget to subscribe. And today's topic, we are going to discuss the distinguishable permutations of an object taken R at a time. Now let's have the objective. At the end of the lesson, the students should be able to find the number of distinguishable permutations P of n object, where P objects are alike, Q objects are alike, and R objects are alike, and value the concepts of distinguishable permutations in solving real-life situations. It is important in solving permutations to fully understand what is asked, like, is duplication allowed or is duplication not allowed? Finding the permutations of an object differ from one another like the two words below. The first word is scholar and the second is statistics. In the word scholar, there is no duplicated or replicated letters, so the letters are distinct. This is an example of permutations taken R at a time. In the word statistics, S and T are replicated and I is duplicated, so the letters are duplicated or replicated. This is an example of distinguishable permutations. How can we find the number of distinguishable permutations? The number of distinguishable permutations P of n objects where P objects are alike, Q objects are alike, and R objects are alike, and so on is P is equal to n factorial over P factorial, Q factorial, R factorial, wherein n is the number of objects, P, Q, and R are the objects with corresponding repetitions. Now let's have the examples. In how many ways can you arrange mathematics if duplications of the arrangements are not allowed? Let's have the given. N equals 11, M equals 2, A equals 2, T equals 2. Substitute in the formula P equals n factorial over m factorial, a factorial, t factorial is equal to 11 factorial over 2 factorial, 2 factorial, 2 factorial. 11 factorial is equal to 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is equal to 39,916,800 all over 2 factorial 2 factorial 2 factorial is equal to 2 times 1 times 2 times 1 times 2 times 1 is equal to 8. 39,916,800 divided by 8 is equal to 4,989,600. Let's have the next example. In how many ways can you arrange payapa if duplications of the arrangements are not allowed? Let's have the given. N equals 6, P equals 2, A equals 3. Substitute it in the formula. P equals n factorial over P factorial, A factorial equals 6 factorial over 2 factorial, 3 factorial. 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1 is equal to 720 all over 2 factorial. 3 factorial is equal to 2 times 1 times 3 times 2 times 1 is equal to 12, and 720 divided by 12 is equal to 60. Let's proceed to the next example. In how many ways can you arrange bayanihan if duplications of the arrangements are not allowed? Let's have the given. N equals 9, A equals 3, N equals 2. Substitute in the formula P equals n factorial over A factorial, N factorial equals 9 factorial over 3 factorial, 2 factorial. 9 factorial is equal to 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is equal to 362,880 all over 3 factorial. 2 factorial is equal to 3 times 2 times 1 times 2 times 1 is equal to 12. So 362,880 divided by 12 is equal to 30,340. Let's have the last example. In how many ways can you arrange karanasan if duplications of the arrangements are not allowed? Let's have the given. N equals 9, A equals 4, N equals 2. Substitute in the formula P equals N factorial over A factorial, N factorial, equals 9 factorial over 4 factorial, 2 factorial. 9 factorial is equal to 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is equal to 362,880 all over 4 factorial. 2 factorial is equal to 4 times 3 times 2 times 1 times 2 times 1 is equal to 48. 362,880 divided by 48 is equal to 7,560. Now remember this quote: success is ultimately realized by people who make more good choices and recover quickly from their bad choices. Our personal and professional success depends on repeating good choices day in and day out and avoiding repetition of bad choices. By David Cottrell. Thank you for watching. Keep safe always. God bless us all. Bye-bye.